from Capricorn Technologies Private Limited. So today I'm going to give a session on modeling steel frame and adding connection using Revit Structure. So let's begin with the webinar. So I'll be discussing about the steel frame, steel connection, and customized steel connection in this webinar. So directly, let me go to the software. So we have a poll question here. Please answer to the poll question mentioned over here. Currently, which product are you using? Okay. All right. So let me start with the session. So here I'm going to open a new project by using the structural template. So here I'll be deleting the analytical levels because right now we don't require that. Okay. So first of all, I want to create levels. So let me go to the south elevation and I'm going to change the levels. Let me just put this level as 0G, for instance. And here I'm going to change the level to 4000. And IF. Again, I'm going to change the level, giving an offset of 4000. An offset of 2000. So here I'm going to change it to second roof. And here I'm going to change it to third apex. Right now, the levels are ready. Now I'll go to the ground floor and create grids. So let me just create grids. It allows that of instance, let's say 4500 and just spacing over here. And again, here I'm going to change it to A and again grid. Now we are ready to go. So now we are ready to place the columns on these particular grids. So for that, I'm going to the structure tab over here and select my column. So I can choose any of the sessions. Now for this example, I'm going to choose UC 356, 368, 129, and I'm going to place over here. So I can change the orientation by spacebar. So I'm just placing it over here on all the grids. You can use at grids option also. So now it's done. I'm going to select this and mirror it across here. Now I can change the height to 2R and the base offset to be 0. Now when you go to the 3D, you can see the columns have been placed with the section UC 356, 368 and 129. Now I have to place rafters over here. To place the rafter, I have to specify the reference plane. So what I'm going to do is I'm going to the south elevation and I'm going to set the work plane as we have so many grids and levels as work planes. So here in the 3D view, you can see we are placing it over these two columns. So E is the nearest grid. So what I'm going to do is going to the south elevation and I'm setting the work plane as, let's say, E. Grid E will be the work plane. Now I can go to the beam again and choose a section which we require. So for instance, I'm going to choose UB 305 165 40 and make sure 3D snapping is off. And I'm going to place it over here. Yes. So now when you go to the 3D, you can see the rafters have been placed. Now let me go to 2R and the detail level should be fine for visibility. Then I'm going to select these two rafters, which I have already created, and going to copy it in other grids as well. Right, say escape and go to the 3D. You can see the rafters has been placed over the columns. Now the next step, what I'm going to do is I'm going to place tie beams over these columns and beams. So for that, I'm again going to 2R. And for tie beams, I'm going to choose a beam section. Let's say, let it be 254, 102, 28. And I'm going to place it over here. Similarly, you can place it, or otherwise you can mirror also to reduce the time. Now the tie beams also has been placed over here. Sorry, I forgot to mention about the foundation. So let's go to 0G, and here we have isolated foundation. We have two different options. So right now I want a different section. So what I'm going to do is I'm just going to edit type and duplicate. I want a section which is 1200 by 1200 by 450. So let me say OK and change the dimension to 1200. So now it has changed its dimension, and now we can place it over here, over the grid intersection. Okay, then we can choose it, filter it, check the structural foundation, and you can mirror it. Now we have placed the foundation as well. Now the next step is to create purlins, to place purlins on this rafter. So for that, I'll go to the south elevation, and the purlins will be placed on top of this particular rafter. So what I'm going to do is go to the 3D view, and first of all, what I have to do is I'll go to insert tab over here and load the section which is suitable for purlin. So going to the structural framing over here and light gauge steel. So we have a number of options available over here. For instance, I'm going to use light gauge as purlin, load it. Once you load it, you will get different types of purlins. So you can choose any one of this as per your requirement. Now, right now, I'm going to select 142Z20. So it has been loaded into the project. So when I click on beam, you can see the light gauge purlin 142Z20. So make sure you click on the 3D snapping because we are in the 3D, and just select the snap points. Okay, it's done. So now when I go to the south elevation in the wireframe mode, the purlins are situated in the rafters in this position. This is entirely wrong. The purlin should be placed on top of this rafter. So what I have to do is, this is a mistake which I have done. So how I should correct this mistake? I should select this and delete it. And I have to mention a reference plane over here so that the purlins will be placed on top of this rafter. So for that, I'm going to specify the reference plane by picking the line. Let me just pull it out a little bit and give a name. So for instance, I'm giving roof purlin. It is up to you what you have to give the naming. All right. Now I'm going to the 3D view and set the work plane as roof purlin. Okay. So if I go to show, I can see the work plane has been set like this. Okay, you can switch it off. And again, I'm going to place the purlins. So you can see the difference right now. Go to the beam and make sure 3D snapping is on. And to beam, and just click on the snap points. Okay. Go to south elevation. Now you can see the purlin has been placed like this. So now also we have to adjust the purlin position because it has to be exactly on top of the rafter. So we have an option called justification points. So when I click on justification point, and I can manipulate using all these grip points. So if I select on this particular bottom origin grip point, it will go up. So this is the way I have to place the purlin on top of the rafter. So let me just move it a little bit. Okay. Now when you go to free apex and detail level as fine, you can see the purlin over here. So I just want to extend it till the end. I'm gonna extend it. Here also like to extend it. Okay. Now when you go to the 3D, you can see the purlin has been placed. Now I want to place it over the entire rafter. So what I'm going to do is go into the south elevation, click on this particular purlin, and we have an option known as array. So click on array, and here we have to specify the number of purlins to be placed. So since I have calculated the distance, I can easily give the number as 7, and I'm going to place it at a distance of 700. So you can see the purlins have been placed on top of the rafter. Now, let me select this particular purlin and right click. So here you have option select all instances visible in view. So I'm going to select all visible in view, and I can easily mirror it. Now you can see all the purlins have been placed properly. So this is how you create purlins. So make sure the reference plane is always drawn and the work plane is set for the particular location where you have to place the purlin. Then only it will be aligned according to the direction of the rafters. So the next thing which I want to show you is how to place bracings. So for that, I'll go to the 0 ground level, and in the view tab, you have an option called framing elevation. So when I click on the framing elevation, I'll get a section like this. So I'll place it in between these two. So let me just place it like this. Okay, escape. And when I click over here, I'm getting a grid point to extend it. So I want a framing elevation between the C and E grid line so that I can place bracing over that grid. So once I have done that, I'm just double clicking over there, go to the fine detail level and click on the framing elevation, and with the grid points, just extend it. All right. So once I have extended it, I want the snap points to place the bracings. Right now, I don't have any snap points to place the bracing. So what I'm going to do is, I'm just going to select the section which I require. So node family again, structural framing and steel. Here I have certain sections which I can use for bracing. So right now, let me just use the CHS section, load. So you can choose any one of the above. So before choosing that, I need grip points. So for that, I want to place the reference plane to get the grip points. So let me just go to the reference plane. And since I know the middle distance of this particular beam, what I'm going to do is I'm going to specify the distance, which is the midpoint, so that I can get the grip points. Okay. Just pull it out. This is how I got the snap point. Now I'll go to beam again. So you have the section. So you have the grid point as well. You can place it as you wish. So in between, if there is any beam, you can choose that also and check the middle point and place it. So this is the way you place bracings. And once you do that, you can mirror it also by the mirror function. Let me just select that. Okay, if I you can see it has been selected using the mirror function. I'm going to place it on the opposite side as well. So it has been placed. So this is the way you can use the steel frame model. Like these are the different options to use the steel frame. You should go to the insert tab and load the Autodesk family, and you can place different sections as per your requirements. So this is the basic steps of creating a steel frame. So let me just close this and go to the steel connection. So this is a model where I'm going to place the steel connection. So as I have mentioned in the previous webinar, we can use steel automation to place the steel connection. So in the previous webinar, I haven't mentioned how to place the connections manually. So let me just explain how to place the connections manually. So as you can see, if you go to the steel tab over here, you can find the connection which has pre-programmed connections by Revit. You will find here three other functions, that is fabrication elements, modifiers, and parametric cuts. So for the today's session, I'll be discussing about the fabrication elements basically. And for the upcoming webinar, I'll be discussing more on modifiers and parametric cuts and more about user-defined connections as well. So right now, I'm going to explain how the connections are put and how you can use the fabrication element as well. So first thing we'll do is, whether we are in a steel tab or structure tab, you can see connection in both the tabs. In Steel tab also you can find connection, and in Structure tab also you can find connection. So it's up to you to decide where to start with. So here, let me just go to the Structure tab and Connection. Here you will find connection settings, which will help you to load all of the connections. So if I click over here, you can see all the pre-programmed connections given by Revit. So I can choose whatever connections are required for that particular project, and you can remove whichever is not required as well. Always it is recommended to load the needed connection to avoid confusions. For instance, I'm going to load apex haunch, base plate, and clip angle. Then I would like to download double side clip angle. Then let me just load neo frame bolted with haunch. And finally, I would like to load tube connection with sandwich plates. So it is up to you, whatever connections you load here, it will be available to be placed on the particular project. So let me say, okay, so I've loaded this connections. I can link to the connection part. Secondly, let's check how to put the connections. So what we have to do is, either you are in Structure or on Steel, you have to go to the Connection tab over here. So if I'm in Structure, let me go to the Connection. And right now I want to put a connection which is for this particular bracing and this collar. So if I pull down, I have tube connection with sandwich plate. So I'll just select this column, control, select this tube as well, and say enter. So you are not able to see the connection because the detail. I'll go to the connection part over here and go to the tube connection and select the bracing and the column and say enter. So go to the detail level fine. So you can see the connection has been placed over here. So what I'm going to do is, I'm just clicking on this particular connection. So in the property dialog box, you have override by instance. So if I click on override by instance, parallelly modify parameters will pop up. Before it was not there. When I check it off, this is not available. So when I click on override by distance, it comes up. So if I click over here, modify parameters, I can edit all the parameters which are related to this particular connection. So this is very easy to manipulate because we can find an image as well to know what kind of parameters we have to give as input over here. So what I'm going to do is, let me go to the gusset plate parameters. And here, if I want to change the thickness of the plate, I can do that. And if I want to change the projection, I can do that. So for instance, the 2 over here is the projection 1, which is represented over here, and which is the plate with the other plate. And 3 over here is the projection 2, which is the plate with the second side. So this is how you should understand. There is an image where all these values are written in numbers. So let me just go to the sandwich plate, for instance. And here I have different options. Like I can change the thickness. I can change the distance and edge distance of sandwich, as well as the gap. Everything are written over here. So if I go to the bolts and wells, I can change the diameter of the bolts. So for instance, I'll just zoom in and show you. Okay, if I'm going to change it to 10 mm, you can see automatically it gets reflected in the project. Whatever changes you make, it automatically gets reflected in the project as well. So once I'm done with all the parameters over here, I can close this tab. And what I do is just click on this connection, right click, and you can see one option known as propagate connection. So once you click our propagate connection, it will take few seconds to propagate to different other similar connections as well. So you can see it has been propagated over here. It has been propagated over here, here as well. And if you go to the other side as well, it has been propagated. So this makes the task really easy. It takes less time to propagate as well. So all the iterations can be reduced. So this is the function which we can make utilize in Revit. So next, let me just show you a different type of connection. Let it be FX haunch. So if I go to the structure again, you have connection. Click over the connection, change it to FX haunch, and I'm going to select this particular rafter and this particular rafter. Select it and say enter. So go to connection, go to Apex haunch, select this and select this control and say enter. Connection. Enter. So here I'm going to change it to Apex haunch. So this is how it looks like. So if I select over here and go to override by instance, as I have mentioned before, the modified parameters comes up and you can change the dimensions as per your wish. So let me just change check the end plate thickness. If I want to change the end plate thickness, I can change it. And if I go to the haunch one, I can change the haunch profile. I can put it as, let me just zoom in. So if I change the profile, it gets reflected. If I put it as none, it gets reflected. Here, if I put it as plates, it will again be shown over the project. So this is how you can modify it. And if I go to the haunch 2, we can change different properties. If I go to the bolts diameter, if I go to 10 mm, you can see the changes happen right away. So if I want to change the stiffener also, we can do that. If I put it as none, you can see the stiffener disappears from this particular connection. So this way you can manipulate the properties using the modify parameters tab. So you have to go into each of these properties and check what are your requirements and input the values according to your requirement. So after that, you can finish it. Then you have to select the connection, right click and propagate connection. So you can see the connection has been placed on all other apex as well. Okay, so this is really simple. It reduces a lot of time. Then let me go to another connection. Let's say clip angle. What I have to do is I'll just go to the column and beam and I'll select the elements. So first the column, then the beam, say enter. So clip angle has been placed over here. So if I click over here and again override by instance, modify parameters. So you can see various properties related to clip angle. So if I want to change these parameters, I can do it. Suppose if I want to change the vertical bolts, you have all these parameters available, which you can manipulate according to your requirements. Then if I want to change the horizontal bolts, I can change it. If I want to change the bolt parameters, I can change it. Suppose if I am going to change the diameter to 10, you can see it gets reflected in the project as soon as I change it over here. So once it is done, what I'm going to do is I'll just close it and again select it, right click and propagate connection. So it will take a couple of seconds to place it on all other similar joints. So now, right now I have discussed 3 connections. So we have 3 more connections left out. So here we can place a neo frame bolted. So connection again, go to the neo frame bolted with haunch. I'm going to select the column and control, enter. So you can see the neo frame bolted with haunch has been placed over here. So what I'm going to do is, again, I'll go to override by instant, and what I'm going to do is modify parameters, and you can change all the parameters over here. Suppose if I go to calculate, I can change it to none, half, full, value. All these things will be reflected in the project. You can see the difference, half, full, all these values. And if I go to end plate, I can change the thickness, and end plate projection, I can change. All these things we can do over here. So if I want the, let me say an example, if I want the column to be projected, what I can do is like this column to be projected above. Here I have an option called column extension. So if I give a value of 150 over here, you can see the change as soon as I input that value. The column gets extended to 150. So this is how you manipulate the parameters of the connection, and just close it and click over here and right click, propagate connection. So you can see it gets placed on all other joints as well. This is how you place neo frame bolted connection. And one more connection I missed out is base plate. So if I go to the structure again, connection tab, choose the base plate, select the column, say enter. You can see the connection has been placed. If I click again, override by instance, you can modify parameters. I think it's going repetitive. You have to change your values as per your requirements, and just close it and right click, say propagate connection. It gets placed over all other columns as well. So this is as simple as to place the connections over all other joints. So this is the way how you place connections manually. So last time I have mentioned about structural automatic connections, which was even more simpler. But if you want to custom connections while placing, you have to use this manual connection method. So next topic, what I'm going to discuss here is a little bit of custom connection, but not covering the full, because in the coming webinar, I'll be giving a session on completely custom connections, also the second part of steel connections. So let me just close this, and I'm going to open the custom connection part 1. So here you can see a column with a circular shape and foundation along with it. So now just let's explore the steel tab over here, which includes the fabrication elements, modifiers, and parametric cuts. So I have explained that I'm going to discuss about fabrication elements right now. Later, we will discuss about modifiers and parametric cuts. You have different options available for steel connections. So, for instance, you will never find in the pre-programmed connections in Revit any kind of circular plate for circular column. So what you have to do is you have to create the circular plate for circular columns. So let's try doing this with an example like this, wherein I have placed a column, circular column along with the foundation. So, and I'll show you how to customize it, break it, and rearrange it again. So this is the discussion today. What I'm going to do is I'm just going to place circular plate over here. One of the very important things that you have to take into consideration is use reference plane whenever you place your connections. So the reference plane will help us accurately position different bolts and wells. So make sure the detail level is always fine. You have to always be in fine detail level. So first thing what I'm going to do is I'm going to go to the structural plan level 1 and I'm going to choose this particular column along with the foundation. And in the steel tab, you have an option called plate. When I click on plate, I have different options to draw the plate. So right now, this is a circular column. I'm going to choose the circle option and I'm going to pick the midpoint and let's say a diameter also and say finish. So this message will be coming like the created elements are visible in detail level fine. That is what I have explained before. You have to make sure the detail view is fine always. So I'm going to go to the detail level and make it as fine. So now the plate is visible. If I click on the plate, I can change the thickness of the plate as well. So for instance, I'm going to change it to 25 mm. And you can go and check it in the 3D view. So in the 3D view, you can see the column edge is actually not seen properly. So what I'm going to do is I'm going to make changes in the elevation view and merge the column and plate together so that the edges are properly visible. So for that, I'm going to go to the north elevation. Again, you have to go to the detail level as fine. And you can see it overlaps each other, the plate as well as the column. So I have an option known as shorten. So if I click on shorten, you can select the column and with this line, we can modify the length. So I'm going to give it as 25 since the plate distance is 25 and click apply. Okay, now when you go to the 3D view, you can see the edges clearly. So this is the method which I have adopted to see the edges clearly. I have shortened the column by 25. Now again, let me go to the level 1. Now you have the plate available. Let me just put bolts on it. I'm clicking on bolts. I'm clicking over here and click on the circular plate. So you have an option called circle. So go to select circle and specify a particular diameter by which make sure that the bolts are arranged along the diameter of that plate. So let me just put a particular diameter for that. Okay, say finish. So you can see 3 bolts are available in this particular plate. If I click on this bolt, in the properties tab, you have numbers. So you can change the numbers as per your wish. So I have changed it to 6 numbers. And if I click over here, I can change the diameter, I can change the grip length, all this is possible. So if I click over here and put 24 mm, it automatically gets reflected in the project. So let me just go to the north elevation again and go to wireframe. So you can see the bolts is not penetrating inside the foundation. So what I'm going to do is click on the bolts and you have grip length over here. So grip length, I can choose any of the length, make sure it goes inside the foundation. So let me just put a value like this now. And you can see it automatically gets reflected in the project. The bolt length has been increased. So go to level 1. Now you have placed the bolts. So this is the way you place the circular plate and bolts. Now I want to give a stiffener over here. So what I'm going to do is, I'm going to the north elevation. So I want to draw stiffener in this elevation. So I always mention that whenever you draw the beam or whatever it is, stiffener, anything, plate, you can just go to the set reference plane and set the work plane. That you have to always do so that it will be aligned according to the view. So let me just click on the set work plane and change to grid 1 because it is in the grid 1. All right. After that, again go to the steel tab and click on plate. I'm gonna draw it. So click on this. Just close the boundary. Say finish. Now when you go to the 3D, you can see I have created a plate over here. All right. So I just want to place the stiffener on all the sides of this circular plate. So what I have to do is go to the level 1 again. So you can see this is not aligned in the center. So I just use the move option and pick the center point and place it exactly on the center. So now it is placed on the center. So now I have to place these plates like stiffeners all around the circular plate. So I can use the modifier tab to use that. In the modifier tab, if I rotate and place it, I have to mention the center of rotation. Just choose the grip point, rotate it to the other side. Okay, so now it has been placed on this side. Again, I want to place it, go to rotate, center of rotation, click over here. Make sure the snap point is correct. Let's say 60 degrees. Now I can mirror it. Now it has been placed on both sides. Again, I can use the mirror function to place it on other side. Now you can see the stiffeners has been placed all around the circular plate. When you go to the 3D view, you can see the stiffener has been placed all around the circular plate. Okay, so just go to shaded view. And now I want to use the weld option here. So click on weld. I want to weld the stiffener to this particular plate. So what I'm going to do is select the plate, control, select the stiffener, say enter. Then you will get a grip point like this. So you can choose the weld line. So if I select this weld line, click over there, you can see the weld has been created. Parallelly, you can change the properties as well. If you want to change the thickness to 4, you can change it. It gets applied over here. And again, if I go to steel and I want to place a weld on this stiffener and this column, what I'm going to do is select the column, control, select the plate, select the column, control, select the plate, enter. So again, I get the grip point. This is the line. Press it there. The weld is placed over there. You can change the thickness of the weld as well. So this is how you place welds. So now we have given everything like the stiffeners, plates, bolts, welds, everything. So if I want to save this particular custom connection in our project, what I'm going to do is I'll go to structure again, go to connection, and I'll just place it over here, say enter, and go to wireframe. You can see a connection, generic connection over here. So now you have an option called customize. Select customize and you can type as per your requirement. Let me say circular plate with stiffeners. Say okay. Now you have to add the connection. So, sorry, there is a mistake. I have to choose this one actually. So if I click over here, column, sorry, connection, wireframe, enter. Now customize it, circular plate with stiffness, say okay. Now you have to add whatever you have created over there. So let me just add it, say finish. So when you go to connection, drop it down, you can see whatever you have added here, circular plate with stiffness. So let me just put it over the other one as well. Select it, drop it down, circular plate with stiffness. Now I have placed this to this column. And if I select this particular connection, I have an option called break as well as edit. So edit means, I'll show you how it happens. Remove. If I remove this particular plate, say finish. Okay. So this plate got removed. Similarly, this plate also got removed. So when you use edit, all other connections which is placed over here gets affected. It gets changed. So what I'm going to do is, I'm just clicking over here, use the break option. If I break this one, it doesn't affect this particular connection. So here you can see it has been broken, like different stiffness, different bolts and different plates. It is not no more a connection right now. So what I'm going to do is, I'm just going to select this bolt. If I change it to 4, let's see what happens. So it hinders the stiffener over here. So I'm going to delete the stiffener as well as the opposite one. Now let me save this as a connection. How I can save this as a connection is, again go to structure, connection, let it be wireframe, enter, customize, circular plate with connection, type 1. So I'm changing the name. Say okay. Now I have to add everything. Say finish. So once it is finished, I can go to the connection again. Go to the generic connection. You have 2 types of customized connection. That is circular plate with connection type 1 and circular plate with stiffness. So what I'm going to do is, if I say connection over here and press enter, I can drop it down and choose whatever I require, whichever is my requirement. So if I click over here, you can see this particular connection has been placed over here. And suppose if I go to connection and say this column, enter, this particular connection can be placed over here. So it is up to you which connection you have to place. So this is how the custom connection works. So we have more topics in custom connection. We have different examples which I have to show you. So we will be discussing everything in the next webinar, because if I talk about all this, it will be really confusing. So I hope the session was informative. So let's, I have one more poll question.